Chapter 8, Lesson 2 is about the slope of the line. We're going to be looking at how to calculate the slopes of lines. So this states that the constant rate of change of a line is called the slope of the line. And remember, we talked about constant rate of change before, and we said the rate of change was equal to the change in y over the change in x. And today we are going to see how those, that's kind of hard to see, isn't it? Maybe I'll change it up with a little bit of, we'll just go here. So the rate of change equals the change in y over the change in x. All right, so let's look at here. This states that the rise is the difference of the y values of 2 points on a line. Now, the difference of the y values is the same thing as the change in y. And they're calling the change in y a new name. They're calling it the rise. So what that means is the change in y is also called the rise. Then it talks about the run. The run is the difference in the x values of 2 points on a line. So the difference in x values, that's the change in the x values. So now the change in x is also called the run. So we have the rise over the run, and that's really the slope. The slope of the line is the ratio, which means we're dealing with a fraction, of the rise, which is on top, to the run for any 2 points on the line. So here we go. The slope is equal to the rise over the run, which is equal to the change in y over the change in x, which we talked about before is the same thing as the change in y over the change in x. So really, slope is actually the same thing as the rate of change. They are exactly the same. They are just called different things and use different symbols at times. It says, remember that y is the dependent variable and x is the independent variable. So let's look here. We have an equation of a line. If we look at this point, we're comparing it to this point right here. And what we can see is that this point rises by 1, 2, 3 units. Okay, so its rise is 3. So if I was going to talk about the slope of this line, it would be the rise over the run. And what's happening? It's rising 1, 2, 3. So the rise equals 3. And the run, it goes over, that's talking about how far it goes from the x values. That would be 1, 2. So the run is 2 units, and we're going this way, this direction, so it's positive, and we're going up. So it's also a positive y. It's a positive y, and it's a positive x. And so that's what the slope is. The slope is 3 over 2. Now, in this chapter, you'll use an m. An m that is a symbol for the slope. So you could say the m equals 3 over 2. And that would be the slope. Now let's check and see if this slope is true for all points. Okay, so now we're at this point. So the slope should be the same. We should go up. We should rise 1, 2, 3, which is what we did, and then go over, run 2, 1, 2. And that's how we have arrived at this point. And then the slope should be exactly the same from this point to this point. Let's see what happens. We rise 1, 2, 3. Yep. And then over, we run 1, 2. And yes, it is still rising 3 and over 2. So the slope is 3 over 2 for this particular problem. Now let's talk about a variety of different slopes. Look at all these pictures. We have these wonderful, dropped that. That didn't work out too well. Wonderful linear lines here. There are pictures right there. Okay, so what we're going to do is we're going to take a point on that line, and let's just say it's right here. Let's just talk about the slope. Remember, the slope is the slope equals the rise over the run. Okay, and we're just going to talk about the rise of this line. Okay, so if we were from here to here and we were going up, we would be going up in this direction, which would be in a positive direction. So I think it's safe to say that our rise would be positive. Okay, it would be some type of number for this graph. We don't know the number, but we just know that it is a positive. And then it would be going this way. The run would be going this way, which would be also a positive run. And it would be some number. We don't need to know the number. We just know that from here to here, we would be going a positive rise and we going a positive run. And a positive divided by a positive is always a positive number, which means this slope is a positive slope. Any type of line that looks like that. It could be like this, 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 this. Those are positive slopes. Now, let's look at this next line right here. Okay? And let's say we just picked any 2 points on this line. Let's say we picked this point here and this point here. So we're going to talk about the slope of this line. So we're going to look at the rise over the run, right? Okay. So if we're starting here and going to this point, what we're going to be doing is we're going to be going down. That means our rise is actually going to be negative. So it would be some type of negative number. We don't need to know what negative number. We're just going to know that it's negative. And divided by the run, so we went from here, we're trying to go from here to here. So we go down, so it'd be negative. And then the run, though, the run would be positive. Okay. And what do we know about a negative divided by a positive number? Well, a negative divided by a positive is always a negative slope. So anything pointed down like this, whatever it would be, that would be a negative slope. So this positive, something like that, negative. All right, let's look at these next two. These are kind of fun. Now, let's talk about what type of slope this is. These are special slopes. So we know, what do we know about a slope? We know that the slope is always the rise over the run, okay? So the rise would be talking about the y value. So here, let's pick 2 points here. All right, so from here to here. Are we rising? Are we elevating? Are we going up? I'm going to say no, we're not going up at all. It's actually the exact same. So the rise is 0 over the run. Well, yeah, there's run going on, and I would say it's in a positive direction, so we could say the run is positive. But this would be a number. So let's talk about what is 0 divided by a number. So I'm just going to throw one out. What's 0 divided by 8? Well, it is 0. Let's do a different one. What is 0 divided by 12? It's 0. 0 divided by any positive number, or even negative number for that matter, if we went from this point to that point, it would be a negative run, is 0. So a horizontal line like this one right here has a slope that is a 0 slope. So it has a slope of 0. All right, let's talk about this next one. This line right here. Okay, now this line is a vertical line. We're going to go ahead and just pick any 2 points on there. I'm going to pick this one and this one, okay, and talk about the slope. So the slope, again, is the rise over the run. Okay, so let's say if we went from this point to this point, okay, would we be rising? Yes, we'd be rising some type of number. I don't need to know what the number is, but I know that we would be rising a positive number. It would just be a positive number. So we'll say it would be a positive number, okay? Now, let's talk about the run, the x values, the change in the x values. If we're starting this point and going to this point, does the x value change? This would be the x value, whatever it is. I don't know, it doesn't matter. But is it change? No, this x value is exactly the same as this x value. So the x value does not change. There is no change. So this means that the run is actually 0. Now, anytime you have a 0 in the denominator, What that means is that the slope is undefined. So you'd use the M, for M is the symbol for slope, and you could say the slope is undefined. So a vertical line, the slope is undefined. Over here, a horizontal line, the slope is equal to 0. All right, so let's look at some problems and see how. So there we go. Recap: positive slope, negative slope, 0 slope, no matter where it is. Horizontal lines are always 0 slopes. And vertical lines are undefined slopes. And lastly, the slope is the rise over the run. Okay, let's look at some examples. This is the first example here. So we are looking at, we're going to find the slope of this line. So remember, the slope is the rise over the run. Perfect. So let's look at this. What is it rising? From this point to this point, we're going up, so that means it's a positive, and it's a positive what? Positive 1, positive 2. So we're rising a positive 2. Now, what are we running? Well, we're going from here to here. We're going in this direction, so it's positive. It's a positive, we're starting here, so 1, 2, 3. So that would be a positive 3. So that means that the slope is equal to 2/3. The rise is 2 and the run is 3. Up 2 over 3. That is the slope. All right, and that's how you show your work. Now it is your time to check it out. You are going to do example number 1. You're going to find the slope of this line, and I know that you can do it. So it is our friend the Pause Dragon, and he's back to remind you to pause your video or whatever electronic device you're viewing this video on, and come back and we'll look at this problem in a bit. All right, see you in a bit. Okay, we are going to find the slope of this line, and remember, the slope of the line is the rise over the run. Okay, so let's go from this point to this point. What is happening? What is it rising? So if we go here, we're rising in a positive direction, so that means the slope is 1, 2, 3, 4. That's 1, 2, 3, 4. So the rise is 4, and let's see what the run is. Okay, so now we're going this way, and we're going this way, which means we're going in a positive direction. So we're going 1, 2, 3, 4. All right. 1, 2, 3, 4. Perfect. So the run is also 4. Okay. So we have that our slope is 4 over 4, or if we reduce it because it's a fraction, what number goes back both into 4 and 4? Well, we know that 4 does. 4 goes in there one time, and 4 goes in there one time. So it's really 1 over 1, which is the same thing as just 1. The slope is 1. All right, if you got that right, great job. We will see you next time.